Hello and welcome to this Millennium Efficient Lab Management webinar. I still see some people that are still joining, so we can wait a minute or two for them to join. While we wait, few things first. So while we wait, if you want, please write the country where are you from in the chat window so we can see where are we all from to maybe see what is the reach of this webinar. And as I said, a few things first, the technical stuff. So the presentation is being recorded and all the registrants will receive the video from this presentation. And while the presentation is ongoing, please ask any questions in the questions tab. You can see that in this in the bottom right, you have this chat and questions tab. So if you have any questions, then please ask them in the questions tab because we will have a Q&A session at the end of the presentation. Okay, so I think we can slowly start. Again, welcome to this efficient lab management presentation. We will be exploring major computerized systems. To start, maybe a few words about me. My name is Sebastian Gruźlewski. I'm the laboratory informatics tech leader in Millennium. I have over 10 years experience in pharmaceutical industry. I started my career as a QC specialist in one of the largest pharma companies in Poland. Then I had a role of a computerized system validation, and then I was a system administrator of all the computerized systems. About my let's say private life. I'm passionate about squash and also flight simulation games. So if you play DCS or Microsoft Flight Sim, then also maybe write me a chat or question so we can play together. What we'll be talking about today. So here is the agenda. So first, you will start from the definition of major laboratory systems, their categories, because often by our customers or people that we work with, everything is a LIMS system. So maybe we can start from some definitions. Then we'll do a small comparison of LES system and a ELN system to say what are the differences, what are the benefits of both. And then we will mostly focus on implementation and usage of a LES system. That's a lab execution system. I'll tell all these definitions in the following slides. So maybe let's actually start. So the first system that is a major one in laboratories is basically a LIMS system. That's a laboratory management system. This is one of the main systems in the laboratory. Its main functionality is to govern the sample workflow, gather different results of different assay. Other functionalities that such a system can do is, well, it all depends on the vendor or if it's built in house. But other main functionalities are basically stability studies and calculation of results that are based on some other partial results. It can also create retests if something went wrong with your analysis, if some human error is made, or if some, let's say, system suitability failed. It's often used to interface to other system basically to retrieve information about sample details, limits, and also it may be used to round results based on the specification of a given analysis. And as with everything, it has both advantages and disadvantages. The main advantage of a LIMS system is basically all results are in one place. It's easily accessible and everything is traceable. So we have all our regulatory requirements filled with such a system because everything is audit trailed, accessible, and available in case of an audit. Everything is just there. For the disadvantages, as this will be common for all the system, well, we have the high cost to set up, and also we need to the setup of the system itself may be complicated both for administrators and users because those are two completely different skill sets that are needed to have this system working in a great way. So different skill set is needed for users to basically use the system and operate in it. And for the administrators, we have this complication of creating all the specification and all the variation of your specifications to be able to meet the needs of your organization in this software. The next system that is commonly used is basically your chromatography data system. So this is something that is provided or you have to buy with any of your chromatography devices. So I don't know, liquid or gas chromatography, you basically need some kind of a software to integrate your data and generate results. What happens is usually this kind of a system is networked with a main server. So here you have some possibilities to have it in-house or in the cloud somewhere. What else with this chromatography data system? It can be also, as all of them, interfaced with other systems to easily transfer data. Like, for example, when you want to create a sample set in, let's say, Empower, you want to fill details like weight, number of injections, amounts, custom fields. You can transfer all this with an interface to such kind of a system. And for advantages and disadvantages, first advantages is, of course, compliance. You have your integrations and all the methods of all your instrumental methods and integration methods. Everything is audit trailed, traceable, and available for inspection. So everything is basically compliant with regulations, if of course configured in a good way. And for the disadvantages, we have, as I said in the beginning, the cost. But the biggest disadvantage of a chromatography data system is actually vendor dependency, because it may happen that some vendors will have better support for their own hardware and worse or none for other competitors. And also, you are here dependent on this kind of software, and any updates you want to do, you need to now analyze if all of your detectors, all of your hardware is compatible with a new version. Maybe you need a new driver. Maybe you even need to replace the whole hardware. It really depends on the software and the vendor that is providing this software. And of course, with everything, we have a learning curve that may be steeper for some new analysts. And now we are proceeding to, let's say, two of our biggest systems. So ELN, we will have in few next slides, we'll have a comparison between ELN and LES, because those two are the ones that are confused most oftenly, because ELN is a electronic laboratory notebook, And what it does is, well, as the name says, it's a digital notebook for gathering your experiment results. It's mainly used in some kind of an R&D department, um, where you have to save your work. You basically do some kind of a discovery process, and you want to have your work notes saved in a organized way so you can use them in future. This system mainly enables you collaboration, sharing results, and all these results are available to do to export. So now what is commonly done is you can export this and perform some kind of a statistical analysis to discover some new things that are common for your results. So as for advantages, as I said in the beginning, actually, you gain a way of storing your data in an organized way. You don't have all these paper notebooks that can get lost or damaged or destroyed in some other way. And you gain an efficient collaboration tool because all has privileges, everything can be shared, so it's available for your colleagues, and they can benefit you all can benefit on your work and collaboration. Well, and also you have this part where you can do data analysis. And for the disadvantages, here we have this technology dependence, where you are basically now forced to perform some kind of a analysis in a way that is kind of forced by your software. So this is one of the disadvantages. The other are same as before: cost and a learning curve. And now the last of the systems, we had to do some definitions in the beginnings because the later part of this presentation uses this definition, but the last one is laboratory execution system. So this is basically a tool that is converting your that is basically creating electronic versions of your paper SOPs. So we take a paper SOP and basically transform it into a electronic workflow. There are some laboratories that entirely stopped using paper SOPs and started creating their methods entirely in a digital way. So they are purely using a electronic solution. In such a system, you often can do some kind of a instrument and reagent management. And also, one of the main benefits is to connect this kind of a system to other systems like LIMS to get samples, chromatography systems to get information from your chromatography, and other systems to retrieve information from your other lab equipment like balances or pH meters or UV meters. All this can be interfaced to a LIMS system, easier or less easier way, but usually it's possible to basically transfer all this information to streamline the process for a lab analyst in the end that is using that is working in your laboratories. As in the last 3 slides, let's go through the advantages and the disadvantages. So here you have a strict adherence to standard. You basically create a workflow that has to be followed by a lab person. They don't have a way of they don't have a simple way of diverting from your process. They have to follow your standard. So one of the benefits of implementing such a system, this can be a great starting point for all the standardization activities, because with an LES system, you will need to have some kind of a standardization across your other systems, so everything works with each other and basically brings benefits to both to all of the system. And for the disadvantages, we have the disadvantage of well, software constraints. Not every software will be able to mirror your paper process. So here we need to do a gap analysis and try to figure out what to do. We will have other slides saying about this. We have, again, software dependency, and we have a training process that needs to be done both for your administrators and lab users, because as I will be talking in later slides, in a LES system, you will need to create a lot of methods, templates. Different systems have different names for basically this electronic versions of paper SOPs. So now a short comparison, because as I said in the beginning, when a customer comes to our company and wants a LIMS system, often it seems like they really need a LES or ELN system. So this is why we just had all these definitions and why we have a differentiation between those two. So LES is mostly used in a quality control environment. So basically where you need strict adherence to a process that is already defined. In an LES system, you can create reagents, you can perform calibrations of your inventory, and you basically perform some kind of a workflow that is already configured. LES focuses on guiding users through a set workflow that is executed multiple times. And on the other hand, ELN system is used mainly in R&D departments. So it's used in things like a discovery process, some refinements of an existing method. It's basically used to capture some experiment information, capture data, and this data is later used in other purposes. And like I said before, we have this strong collaboration and sharing of the experiment data. Okay, so in the next slides, we'll be talking about how to implement a laboratory system, and we will be talking about a LES system in particular. So all the slides from now will be mostly focusing on a LES system. So to start, we need to select a project framework. So mainly we have two ways. The first, and let's say older way, is waterfall, and due to severe complexity of what is needed in such a project, ideas on paper may just not work in a project phase, and they may not work in reality. So actually what I advise strongly is go with some kind of a agile or scaled agile framework, because this will enable you to react faster uh, for gathered feedback. Because often in projects, things that started with some kind of a definition and configuration evolved really fast to a whole different thing, and the project team had to adapt to this to this change. The next thing is requirements definition. So in all projects, this is needed, but for a LES system, it's a giant task that is needed for your project success, because we will need to have so many processes just mapped out, because we are actually rethinking how the laboratory will work in the future, and it has to be really efficient. We need to map all the business processes because they will allow us the easier implementation. Um, we need to think if we will have a global or local system, because this is really different kind of implementation if you have just one site or one laboratory, or we have labs across the world, because we'll have then problems with dates, with sites, with sample segregation, with all these different, for example, time conversions, or daylight saving time. This is different in many sites. Some systems support this just out of the box, some don't, and you need to perform all the calculations on your own. You need to map your sample life cycles, because when implementing such a system, we need to think where we will actually start our process, because we can start in LES system, but we don't have to. We can start from our LIMS system, and if we have it, and interface it to a LES system. What happens with the sample? If it's a happy path, it just transfer information in one way or another, and we are done. But not always it's just a happy path, because human errors happen, system suitability fails, machines break. All this needs to be mapped out somehow, because when we are creating some kind of a interface or workflow, or just create a method, these things have to be taken into consideration to have a great working method for laboratory use. We have to think about our reagent preparation and instrument preparation and their life cycles, because here we also have problems or opportunities that have to be thought about. So can we use a reagent at risk? So if it can we use it if it was not reviewed? How do we ensure that it's safe to use? When we have instruments, we need to define what instruments we want in our system. Is a pipette an instrument? Is it connected somehow to the system? Maybe yes, maybe not. What's a chromatographic column? If it's a reagent or a instrument, all things need to be defined, because later in the way it will be just like a giant snowball effect, which will slow you down in the future. And also, the main, well, maybe not the main benefit, but the benefit of a LES system is integrations with all your other systems, because you want your lab analyst just to have a tablet or something and just to go and do their work, and not to write down the expiry dates, the serial numbers, the results, or basically some kind of a table that is generated by other devices. So it's really good to think about what interfaces you want to incorporate. For example, an interface for a LIMS system or a chromatography system is essential for the success of such a system, because of the benefit that lab people are gaining, because they don't have to do the manual work of writing results from one page to another. The next thing with the requirements definition is you need to think about the environment that your system is running in, because it can be local, it can be in the cloud, it can be some kind of a Windows, Linux, or whatever application that will need, I don't know, some kind of a virtualization layer to be able to be delivered in some kind of a to some kind of a mobile device. You need to take the reaction time into consideration, because the system may behave differently for 10 users. But what happens if you have 1,000 or 5,000 or even more? Um, so that's for the requirements definition. It's the most important part of the project. It's a giant part of the project where you don't have anything actually, but you need to think about how your system will work. Then we have vendor qualifications. So we work with different vendors. I work with different vendors throughout my career, and we had vendors that are really proactive. And if we submit a bug, they will fix it in a matter of, let's say, months, and it will be just fixed and dealt with. But we had a great software vendor that delivered software in a really great state that had, let's say, really small number of bugs, but when we submitted something, we just waited over a year and nothing happened. And sometimes this is a critical thing that is hindering the work of your laboratory. When you are assessing your vendor, your system, you need to think about your evaluation criteria, because the system will be different. I mean, the evaluation will be different for your lab personnel and for your IT team. Basically, your lab personnel may like that it looks great on a tablet, the fonts are nice, and the workflow is really good. But your IT personnel will be more interesting about the technology stack, how the system is installed, how many additional layers of architecture you will need to support. So all this information I said is quite crucial for budgeting and timeline management, because without all these things, without this preliminary phase where we basically define what is needed, it's really hard to create a long-lasting timeline that is accurate in any way, and with that to create some kind of a budget that will fit your needs. So how to implement, what approaches we have? Well, of course, we need to start with the RFP phase, so request for proposal, where we invite our vendors if we are buying a software out of the shelf, because we can also create something in-house. We invite our vendors to show their software and basically perform some kind of a gap analysis to see what fits our needs best, because there are many different LES system, ELN systems, LIMS systems. They are totally different. They have some similarities, but we have, for example, LES systems that are still based mainly on Excel with some additional macros that help it work still somehow. And we have systems that are entirely web-based with modern technology stacks behind. So you need to perform some kind of a RFP phase to pick your best system that will best fit your needs. And when you have this, you still need to collaborate with your vendor about the gap mitigation, because even if you select a system and it fits your needs, it's great. Most likely you will have some kind of a gap in your system, because we have not yet seen a system that perfectly fits all our customer needs. So it's really good to communicate with the vendor about the roadmap, about what's coming, but never buy software on some promises of a vendor that it's coming in the future, because we don't know the future. So um, about and next thing about the software that is kind of obvious at the beginning is some LES systems, some LIMS systems, they come with interfaces built in. For example, there are systems that can communicate out of the box with, let's say, LabX, Labware, or other giant systems that will well, you don't have to create an interface anymore if that interface fits your needs, because that may also be a problem, that a out of the box interface provided by the vendor is just not right for you. For the implementation approach itself, we first need to say a few words about key system modules. So there are different systems, there are hybrids that combine LIMS, LES, ELN, but in principle, let's say that a pure LES system that is used just to create laboratory workflows usually has some kind of a inventory module and some kind of a sample testing module. So a inventory testing module, a inventory management module is a part of the software that is being accountable for creating all your reagents, store the information about the preparation of your reagents, and does kind of the same things for your inventory. Sorry, it stores the information about your inventory and also tracks down your previous checks, validation, and cleaning activities. Um, so this is the inventory management part, and we have also the sample testing part um, where what we do is basically analyze all the samples we have in our system. So what usually happens is you need inventory to run sample testing. So a obvious thing or the logical thing would be to first have your inventory module, then do the sample testing. So let's go back to implementation approach. We can have a big bang or a phased rollout strategy. So the first one is just deliver everything. It's really hard to do if you want to implement it in a laboratory or a site or your whole organization, because providing all methods, and you can have hundreds or thousands of sample testing methods at one go, seems just impossible. So some kind of a phased rollout strategy, I think, is the best way to go, where you implement the system step by step. So you would implement instrument management, you would implement your reagents, and then when you have your, let's say, prerequisites, you would go with the sample testing, where you would use the previously created instruments and reagents. Mm. There is a third system module, let's call it monitoring. You will gather a lot of information in your system, and you may want to export this information so to create some kind of reports, because you will have maybe stability studies in your system. Maybe you have to report to some kind of a regulatory um, body, or you have some other function. Then this is also a good thing to think about when and how to implement. So we need to also be mindful about the scope creep, and at first uh, we should just stick with the minimum viable product, just to not overpromise on our delivery. Okay, about the validation. There are two main parts of a LES system regarding the validation approach. We have the core system validation. So this is, let's say, the easy part, where you do your, usually in a pharmaceutical environment, you will have some kind of a CSV, or computerized system validation procedures, already available. So, or some kind of risk-based approach, GAMP5, or computer system assurance. All this works for core system. Core system is basically just the software, but the problem with such kind of a software is software without the master data or the methods or the workflows. It's not really doing much, and a big portion of your risks lies in your methods, workflows, or templates. This is the really interesting part, where you also need to think about validation of this part of your system, because humans make these methods. This master data is created, these workflows are created by your, I don't know, administration personnel, lab people directly, and then they have to create a workflow that has some kind of a calculation formula. Maybe there are some conditional statements that say if something happens, then do something. Those are places where you can make a lot of mistakes, and you have to check this, because if you don't, you will have problems, and this will be serious problems, GXP related, that may halt your batch release, because you have to be sure that your method is behaving as it was intended to do. You just need to be certain that this is done in the right way. Also, there is a question of regression testing, because you will have updates to your system, and you also need to be sure that even methods that you already created in new version of your software are behaving in the same way. Now let's go through the sample, through a example execution. This part focuses on really on all the benefits that your system provides, and all the risks that may occur, may happen, and you need to combat in your system. So as the prerequisites, you need to have already, let's say, a workflow, a template, or a method ready, and you need to have your map, your business process mapped. So let's say you have all this, and you want to create a task, you want to do the work finally. So first opportunity or problem is you need to create a task, or usually it's called a task, basically a execution that is needed, that needs to be done. To create a task, a sample testing task, you probably need some samples. So here we have a opportunity, basically a challenge. So we need to define where we take this sample from. You may have a LIMS system already available in your system, you may not. Maybe you want to use some built-in function of your system, but you need to consider what happened if the system, if your LIMS system goes down, how to cope with that, because lab work just cannot stop. So let's say you want to interface to your LIMS system. How to do that? Here we already have a problem, because you have a sample in your LIMS system, you have a sample or a method in your LES system. How to link them? There are two basic ways to do that. The easy way is to create a mapping table. So how to do that? Well, you end up with a giant mapping table that has all your methods from one system linked to methods in another system. This may be really problematic, because you will end up with a giant table of thousands of entries that needs to be reviewed and audit trailed, because of all the requirements we have. And also, it's just really hard to maintain, just because of its scale. The second way is some kind of a smart approach, because you have your LIMS method names, and you have your LES system results. Maybe there is a way to link them somehow. In the end, you also end up with a mapping table, but this one can be done, let's say, on the fly by some kind of a automatization software. Okay, so let's say you have your task, you have your samples in your task. Now you need to perform some kind of a lab work. So what usually happens is you need to have some kind of a laboratory equipment, let's say a balance, pH meter, IR, whatever. Just a simple balance can have at least 3 ways of connecting. It can be connected directly via some kind of a serial port. It can be connected via some kind of, I don't know, Ethernet with some proprietary box to your system directly, or it can be connected to entirely different system. So what happens? How do you proceed in this scenario? You need to define where you actually start your process, where the weighing process starts. Do you start from the system, from your tablet, or do you just go to your balance, and your LES system somehow knows what to do? So these are the questions you need to take into consideration, because all this can be done in many different ways, and it really depends on your needs, on your customer needs, and basically what works best in a system. Okay, then we need to basically do the work, conduct the sample preparation, perform some kind of a laboratory tasks, and let's say this is a empower a chromatography analysis. And what is the logical thing? You would like to transfer all the information you already created during this task execution to Empower or a chromatography data system. So what happens is usually the bare minimum is done. This is not a great really solution, because you are making people to write down things that are in electronic systems. So that's really not the way to go. We should focus really on transferring everything. So we have our sample set methods where we can transfer samples, injection numbers, injection amounts, custom fields values. We can transfer, we should be striving to transfer all this information, because this approach actually helps the analysts in the end. Okay, then we need to retrieve this information, and basically with this comes also a problem, because when we retrieve information from a chromatography data system, probably we need to do some calculations. Where to do them? We can do them in the chromatography data system itself, or we can do it in a LES system. Both ways are okay. Both ways have benefits. Both ways have disadvantages. These things need to be mapped out by some kind of a BA long before we started our implementations, because in other way we will have this snowball effect that is dragging us down. Okay, so in the end, we will end up with a final result that needs to be reviewed. And again, we are ending up with we are in a laboratory system that is electronic. So maybe we don't have to review. Maybe we can use some kind of a functionality of our system to do some kind of a automated review process. All these things are possible. All these things can be done, but this is a giant task for your BA team, for your IT personnel team. All this can be done, but it just needs really some hard work to be able to conduct all these functionalities. Uh, Everything will fail. You will have system stability failures. You will have human errors. You will have challenges, because now you have 3 different layers of databases that are interacting with each other. Humans will break glass. Human will do some wrong process steps. We need to be prepared for all this, because the easy part is the, let's say, happy path during the workflow execution. And sometimes, sometimes this unhappy paths happen, and we need to have processes ready to combat these problems. And also, what happens is that your core software may have some bugs which will affect your daily work in different ways. So workarounds and solutions are really welcome and need to be described in some kind of a structured way. Regarding structured way, it's easy if you have your lab system in just one laboratory, but what happens if it's in many different sites in all around the world, where people do things differently? Without standards and without a person or a OCM team, so organizational change management, it will be really hard to work in a certain way, and we will end up in bigger or lesser mess of different workflows and slightly different processes. Maybe that's okay, maybe not, but we need to be aware that workflows from in different labs differ, and it's really good to provide some kind of a guidance for all of these people. Having naming conventions helps because um, one if we have one method and we need to name them, three different people will name them in 6 different ways. So it's really good to have some kind of a naming scheme for basically everything. We can have variables, we can have method names, we can have sample names, instrument names. All this should have some kind of a naming scheme because then we just have a structured approach. Methodology guidelines. So sometimes it's a good approach, sometimes it's bad, but it's really nice to have some kind of a guidance for your personnel that creates your workflows, because if you don't provide that, you will have a really uh, you will have really different you will have methods that really differ from each other. It may be okay, but it may be not. Sometimes you need to create a method in a certain way because some other interfaces or some functionalities rely on a certain way you are creating your methods. And the last but not least is basically work instructions for everything, or SOPs for everything. But what is also great is just to have short videos that instruct step by step how to do a certain thing. And actually, this is the last slide from the presentation. And as I said in the beginning, we will have a short Q&A session because it's 2:45. So let's see how many questions we have. I see we have 3 questions. So the first question is, how, if you still have questions, then please ask them in the question session. If we will have time, then I hope I can answer. But first question is, how long does it take to implement an electronic method? So this is always a tricky question. A simple method in a system that is really, let's say, friendly to use for a developer could be created during this presentation. It's not that hard. It's not that hard, but methods really differ in complexity because some methods are just weigh something or just check the pH and that's it. And some methods, for example, chromatography methods or some bioassay methods, can be really complex. So it's really hard to answer this question because it really depends on the complexity of this method, and also actually the engagement of the SMEs or personnel in the laboratory, because sometimes a person that is creating a method is entirely a different person that will be using this method. So if this is the case, they need some kind of a reviewer, and this reviewer is often occupied by other laboratory work. So the short answer is really from 1 day to a week to a month. It's really different. If everything works, it can be done, let's say, quite fast. What's the hardest second question? What is the hardest method to create in an electronic system? Again, this depends on the system because we have this different system. They have different functionality, all have its strengths and weaknesses. But what is the usual thing is some kind of a biological method that has incubations that take days, and then something may happen with this incubation and you have to discard a part of your execution, and you need to mark this somehow. So usually biological methods, in my opinion, are the hardest ones to implement. The third question. Hi, Sebastian. What is the biggest pain point while implementing an LES system? So for me, actually, 2 things. First is actually resource. resourcing of people. We need to have, if you are, I mean, in the implementation phase, in the implementation phase, the hardest part is actually creating good requirements and mapping them out to system functionalities. But in the implementation phase where we are actually creating already the master data or methods, for me, the hardest thing is to actually have resources that can help let's say the developers to create, to review, to have time to review and approve the methods. This may be one of the biggest pain points, and it just takes so much time. Uh, I think we still have a few minutes, so let's go with one or two more. So, can these methods be built by lab people, or do you actually need to hire a team of devs? It depends, as always. So, for some customers, we have a team that is creating methods. It's a balancing act because you want the lab personnel to do lab work, and you don't really want them to create some kind of a additional work, you don't want them to do some additional work, but the benefit is in future they would do their work faster. We have sites where the methods are created, or tasks or workflows are created entirely by lab personnel. This is great because they just create what is right for them. And we have sites where it's just not an option to have lab people create methods, and we have a dedicated team that creates methods for them. What is the best way to validate such tools? Traditional waterfall approach or agile method? I'm really for the agile method because just when we have when we have this laboratory workflow, it changes. It's not like, I mean, we had a project where we started from requirements and let's say specification document per method. Then we proceeded to first it started from a BA gathering requirements, created a specification document, then a developer started developing, and then they created a great method that fit all the requirements that were in a specification. And when this method was presented to a lab person, they said it's not, we cannot work with this, it's not meeting our needs. So I think only agile methodologies are really good for this, because you just have time to react, an opportunity to react to changing environment. Okay, so I don't see any more questions. So I think actually we can close the QA session, and that's actually it for my presentation. So thank you for attending. Have a great day, and maybe see you next time.
Millennium. IT for people. People for IT.